All right, so what you're looking at right now is pi radians, or 180 degrees. So anytime you're looking at an equation or an expression on it, and it deals with, like a unit circle or a sine or cosine function, when you see pi, you can think of it as 180 degrees, just to kind of, you know, break it down a bit more. So all pi is, it's the relationship of the circumference of a circle and its radius. So remember from geometry that the circumference of a circle is equal to 2 times the radius times pi, right? And we can rearrange those parts of the equation to figure out what those values are. So imagine we have 2 pi, right? So what you're looking at right here is 2 pi radians, or if we flip them both over, 180 plus 180, 360 degrees. All right, so sometimes we'll have a fraction, or let's say we have pi over 2, right? So this is what it'll look like. And if I go ahead and overlay, makeshift unit circle, we'll see that we're falling right in the first quadrant. So if we're looking for sine, or our y value for pi over 2, remember that our radius for our unit circle is equal to 1. So our sine of this, this angle pi over 2 is going to be equal to 1. Now our cosine value, which is our x value, is going to be 0 because we're right at the origin, right? Okay, so sounds simple enough. So again, the biggest thing to keep in mind is that these radians are just a unit of measurement. We're used to using angles, just some arbitrary unit that we've, I'm saying we, but some really smart folks came together and said 360 of these degrees will make up one complete circle. But in this case, we tend to measure radians in terms of pi. So this is pi over 2. So what happens if we've got pi over 3, right? Same deal. And what I can also do, if I place a protractor right over it, then we'll see it's not quite perfect, but pi over 3 radians is dangerously close to 60 degrees. And I'll take it a step further. What if we've got pi over 4? All right, pi over 4 radians. It's going to bring us pretty close to 45 degrees, right? Again, it's not perfect. I kind of cut these a little unevenly, but here we go. And again, we can overlay our unit circle and sort of envision where it falls. So once again, we're in our first quadrant here. Now imagine you have a question that deals with not 1 but 2 pi over 4, right? So what's cool is that this is the exact same thing as pi over 2. If we just rearrange the fraction, it's the same as pi over 2. So 2 pi divided by 4 can also be rewritten as pi over 2. Once again, if we overlay our unit circle, then we'll find that our sine and cosine values are going to be exactly the same. Now, one other thing I'll do a bit more here too. So let's say we have 1, 2, and 3 pi over 2. So I'm not going to get in the nitty gritty here of actually, saying what the sine and cosine values are, but what I will do is show you that if we see 1, 2, 3, or sometimes maybe written as 3 pi over 2. So if we see that somewhere in an expression, there goes the lights, then we'll know that 1, 2, 3, it's going to fall in our third quadrant. So we'll know that our cosine value is going to be negative, and our sine value is also going to be negative. You may see something like, I don't know, cosine 3 pi over 2, right? So when you see something like this, don't be so afraid, because all it is, you just imagine this, right? And then you can, work your math magic. So the reason why all this works goes back to our Pythagorean theorem. So I used to be super confused about why we chose these, you know, these particular special angles, as they're called. Just seem like, were we just choosing random angles here? Well, no, because remember, like with the clock, you can imagine a right triangle within a clock. The same deal with our unit circle. So you have a right triangle, then you can use these special triangles, the 45, 45, 90, and the 30, 60, 90. So what's cool about these, and you can always look this up, I personally don't remember off the top of my head, is that we'll be able to know the exact lengths of the smaller sides for 45, 45, 90. These two legs are going to be exactly the same, and our hypotenuse is going to be related to these, right? It's going to be equal to the square root of 2 times whatever the length of one of these sides are. So we know that our unit circle is going to be equal to 1. So we factor in 1, and then we can do some algebra and determine what our sine, our y value, and our cosine, or x value. Similar with our 30, 60, 90, it's a bit different, but just remember that our shorter side is going to be, some variable, we'll say a. Our hypotenuse, which is, remember, the radius, which is always equal to 1, is going to be equal to twice this shorter side. So if this is equal to 1, but it's twice that, then we know that this side is equal to 1/2. And our longer side, which typically is going to be our sine, is going to be equal to whatever this was, in this case 1/2, times the square root of 3. So I hope that kind of helped a bit. Really just, I'm a visual learner. I don't know if any of you are as well, but, if you got the time, just cut this out, or you can get some cheap foam and try to make one of these yourself, and it'll just make everything a bit easier. So hope it helps. Thanks.